This video is going to look at how we can evaluate functions. And before we do that, I want to look at explaining a little bit about our function notation. For example, if we have the equation y equals, let's say, 4x minus 7, then our function notation means we can rewrite this using f of x. Okay, now all of this, keep in mind, remember, f of x, this is not f times x. F of x here is representing the y value. So we could write this as f of x equals 4x minus 7, and this is the exact same equation. This is just using our function notation where f here is the name of your function, and in the parentheses, this is telling you the variable that we're using here to represent the function. So keep in mind here that this is really f of x. I'm sorry. This says if you plug x in, this would be x, and then f of x here is representing your entire y value. Okay, so just keep that in mind here that when you see f of x, all of this is the same thing as equaling y. So here we have our first example here. We have g of t equals 4t squared minus 3t plus 5, and we want to find g of 2. Well, that simply means that we're going to go to function g. So here's function g. And in place of the t, we want to substitute in 2. So everywhere there's a t, we're going to plug in a 2. So we would have 4 times 2 squared minus 3 times 2 plus 5. And then all we have to do is simplify. So we have 2 squared, which is 4, minus 6 plus 5. So here we have 16 minus 6 plus 5. And 16 minus 6 plus 5, that is equal to 15. So here that tells us that g of 2 is equal to 15. And the great thing about this is when we say g of 2 equals 15, we not only know that y is equal to 15, but that tells us that when x is 2, the g of 2 tells us when x is 2, the y is equal to 15. So when you see an answer like this, g of 2 equals 15, that really means that when your x coordinate is 2, or in this case the t, when that's equal to 2, then your y value is equal to 15. Now, what happens for part B here? We have g of t minus 2. Well, we're going to do exactly the same thing. That means that we're going to take everything here that's in the parentheses. We're going to go to function g, and then everywhere there's a t, we're going to substitute in the t minus 2. So here you're going to end up with 4 times, in place of t, we're going to substitute the t minus 2. So the whole quantity, t minus 2, is going to be squared, minus 3 times t minus 2. Okay, so 3t, so that's 3 times t minus 2 plus 5. So there's all the substitution. So at this point, all we have left to do is to simplify. So then we can square t minus 2. Now keep in mind, if we're going to square t minus 2 here, that really means t minus 2 times t minus 2. And you really have to learn this. I know everybody seems to struggle, but you need to realize when you're squaring a binomial, you're going to have to FOIL this. Or the shortcut says you square the first term, so that would be t squared. And then you multiply the two terms together, so negative 2 times t is a negative 2t. And then you're going to double that. So negative 2t times 2 is a negative 4t. And then you square the negative 2, which is 4. Okay, that's the shortcut. And the reason we double this middle term is because if you go through your FOIL, t times t is t squared, and if you multiply here, you get a negative 2t, and here you get a negative 2t. So a negative 2t gives you a negative 4t, and then negative 2 times negative 2 gives you the positive 4. So if you still have to write this down and multiply it out using your FOIL, that's perfectly fine, but just make sure that you multiply t minus 2 correctly. And now we distribute the negative 3, and keep in mind we're distributing not only the 3 but the negative. So a negative 3 times t is a negative 3t, Negative 3, negative 2 is a positive 6. And now we come back and we have to distribute the 4, so we have 4t squared minus 16t plus 16 minus 3t plus 6 plus 5 here would be 11. And from here we could simplify this, and this is all going to be again g of t minus 2. So we have our 4t squared and 16t, negative 16t, negative 3t is a negative 19t, and 16 and 11 would be a positive 27. And there we have our function g evaluated with t minus 2. All right, now we have part C. Notice we still have the same function. I just copied it over again for us. 4t squared minus 3t plus 5. And for part C, we want to find g of t minus g of 2. So first of all, we need to find what is g of t. Well, g of t is simply going to be our function. That says everywhere there's a t, plug in a t. Well, it's already a t there, so that's just going to be 4t squared. And let's see, I'm going to write it this way. That would be 4t squared minus 3t plus 5. So all that's g of t. And then we want to find g of 2. So it's minus g of 2. Well, convenient enough, we already found g of 2 up here, and we found g of 2 to be equal to 15. So we don't have to go through the substitution again, so we know that we're going to subtract away 15. So in this case, we end up with 4t squared plus 3t plus 5 minus 15. And if you take plus 5 minus 15, that's going to be minus 10. So that gives us g of t minus g of 2. So we simply evaluate the function at t, then we evaluate the function at 2, and then we simply subtract. All right, our next function, f of x equals the square root of x plus 8 plus 2, and we want to find f of negative 8. And again, for this example, you may want to pause the video and see if you can work these out on your own. So now we want to find f of negative 8, so it says go to function f, and again, f is really just the name of the function, so we want to plug in a negative 8, so we would have the square root of negative 8 plus 8 plus 2. So then we end up with the square root of 0 plus 2, and negative 8, the square root of 0 is going to be 0, so then we simply end up with an answer of 2. And I want to emphasize that f of negative 8 equals 2. So again, that really means that when x is equal to negative 8, our y value is equal to 2. So really that gives you the ordered pair, negative 8 and 2. All right, f of 1, we want to evaluate the exact same function at 1, so this is go up here to function f, plug in a 1, so we would have the square root of 1 plus 8 plus 2, and 1 plus 8 is 9, so we have the square root of 9 plus 2, and then of course the square root of 9 is equal to 3, and 3 plus 2 is equal to 5, so f of 1 equals 5. And once again, that tells us that when x is equal to 1, y is equal to 5. And part C, we want to evaluate the function at x minus 8. So once again, everywhere there's an x, we're going to substitute in x minus 8. So we have the square root of x minus 8, and then we have plus 8. And then on the outside we have our plus 2. Now if you notice, I think it's a good habit that you want to get into when we substitute in a value like the x minus 8, you want to make sure you put those in parentheses because that's the whole quantity that we're substituting in. Now really in this case we didn't need the parentheses because this would simply be x minus 8 plus 8 So if you notice here, the 8's are still going to cancel, so you're left with the square root of x plus 2. So when we evaluate the function at x minus 8, we get the square root of x plus 2. So really, if you notice here, it's very simple to evaluate a function. Basically, all you're going to do is take what's inside the parentheses and substitute that into the function everywhere there is an x. All right, here we have what's called a piecewise function, okay? And basically what that means is we have several functions put together to make one function. So if you notice here, f of x equals 4 minus 5x when x is less than or equal to negative 2, and f of x equals 0 when negative 2 is less than x and x is less than 2. So really that tells us that this function is equal to 0 when x is somewhere between negative 2 and positive 2. And then the function is equal to x squared plus 1 when your x value is greater than or equal to 2. So how do we evaluate a function like this? Well, for part A, they want us to find f of negative 3. So we know we're going to go to the function and we need to plug in a negative 3. Well, the question is, where do we plug in the negative 3? Well, we do not plug it in for all three pieces here. We're going to plug the negative 3 into where it fits within the inequalities over here. If we plug negative 3 over here into 4 minus 5x, then that means x has to be less than or equal to negative 2. Well, is negative 3 less than or equal to negative 2? And the answer is yes. So based on this here, we're going to plug negative 3 into 4 minus 5x. So how do you determine where to plug in your number? You simply have to look at over here the restrictions. So because negative 3 is less than or equal to negative 2, we're going to plug it in here and we're going to get 4 minus 5 times negative 3. So we end up with 4 plus 15. So therefore the answer is 19. Okay, and that's it. That's your answer. You do not plug it into the others because in order to plug it into the next one here, your x has to be between negative 2 and 2, and the last one, your x has to be greater than or equal to 2. So now if we want to find for part B, f of 4, well, is 4 less than or equal to negative 2? No. What about the next one? Negative 2 is less than 4. Is 4 less than 2? Well, negative 2 is less than 4, but 4 is not less than 2. So if we look at the third one here, we have 4 is greater than or equal to 2. So is this a true statement? Well, 4 is certainly greater than or equal to 2, so we're going to plug it in for x squared plus 1. So that means we would have 4 squared plus 1, which is 16 plus 1, which equals 17. And then for the last part C, we want to evaluate the function at negative 1. And if we look here, negative 1 falls between negative 2 and positive 2, so that means we're going to use the second part of this piecewise function, which simply says if your x value is between negative 2 and 2, your function is simply 0. So f of negative 1 equals 0. Okay, so if you realize this, your piecewise function is a function that is simply made up of several different functions. It could be 2 functions, it could be 3, it could be 4, 5, however many. But notice you have to look at the restrictions here to determine which part you're going to substitute your number into. Okay, so now hopefully you have an idea of how to evaluate functions.